Muss ich Startsignal? Okay, so welcome to my talk about an OSGi-based platform which we aim to build, which should support Industry 4.0 applications for small and medium enterprises. My name is Harald Konmeier, and I present work which is done together with PhD students and with the support of a few students done at the university in Mannheim, where I come from. The agenda is quite short. I will talk about the business opportunities and challenges of the project, which is somehow interesting because it deals with sustainable buildings, totally different from OSGi, but we will use OSGi to manage cloud and edge nodes, and we have our own data communication model, which makes it quite easy to communicate with sensors and the cloud nodes. And we are currently developing a language which allows us to develop domain models for other domains than the one which I will present. The business opportunities is quite simple. This is not the production outcome from a startup in the Silicon Valley. This is from a small startup south of Ludwigsburg, 100 kilometers from the Black Forest. So they started 6 years or 7 years ago, building something like 8 units of products. And within the next 6 years, they increased it overall by 1,000%. It's a company which builds green and sustainable houses. And these technologies become more and more important. And that was the idea of building a project together with them. So this is the product they built, real houses made of wood. And the cool thing is, really made of wood only, so there is no chemistry in, there is no glue in the walls, and they are massive, so that's different from houses which you can sometimes see in other parts of the world, which are just a structured wood house. No, these are massive, real walls. And just to give you information, a normal one family house they build in 2 or 3 days. All the wall elements when the project is ready. It's so interesting that in principle, what projects they already collaborated with. So together with a company in Netherlands, they built the most sustainable office building worldwide, certified by a certification agency, which claimed that this was 99.94% sustainable. So this means energy production is sustainable, and even the production of all the elements reach that level of sustainability. So that's something which matters in the time when we have something like climate change. What are the business challenges for this small company? Well, in the handicraft industry, like building houses or carpentry, they are also influenced by industrial production. More and more pre-assembled products are available in this domain, and so that's changing, but still a real handicraftsman is committed to his product, so he wants to produce good quality. The challenge for the company which I presented is another one. This was a small enterprise company located there in the Black Forest, and they sold their products before that normally only in Baden-Württemberg, so in the local region. Nowadays they go to all over Germany, Switzerland, Italy, Netherlands, Norway and Japan. So they sold houses worldwide. So from a small company, they go really worldwide, which introduces problems for them. First of all, they have now to collaborate with a lot of partners worldwide, and this should be done in a structured way. Another challenge they have is, well, this house is built of wood. Is wood really sustainable? Is it as solid as concrete? So another challenge in this green technology domain is really to prove that a house has good quality, that it can last long enough. So that's when we started with thinking about, well, this sounds like Industry 4.0, digitalization of productions. And just a reminder what Industry 4.0 means in Germany. It's the horizontal digital integration of engineering in a value network. So the value network in that part is the collaboration between partners We want to integrate the manufacturing system, which is in the company, building a house in 2 days. That's the system which should be in there. And well, we want to improve the process and the product quality. So that's the target that we have in general. And that means, what does it mean when we think about IT challenges? The company, one has to say, is a small one. So the IT department does more or less not exist. So it's only just, they deal with computers, but not in a very structured way. They do it well. They were successful. So the idea was, what can we use? We can use cloud computing infrastructures to build a new system. And we think of sensors in the Internet of Things to build something what we really call a cyber-physical system for houses, which combine both approaches and which will later on enable analytics to be used to find out the quality of all the products which were distributed worldwide. So this is what we then later on aim for a cognitive system. How do they deliver the product? Now, well, this is the company producing the things, the walls. They collaborate or cooperate with distribution partners worldwide, and they normally with the architect. So if you want to build a house, you go to the architect, that one's to the distribution partner. They build together with the customer the whole house. If everything is agreed, it is produced, shipped, installed, and then, last a few decades. And what we want to do is, we want to integrate a business model which goes for sustainability and quality assurance. And it's really a business model. Every one of you has a car, I guess, when it has to be last time in a workshop, 1 year ago. A few of you have a house. When have it been in inspection last time? Never. Strange, obviously, the investment in a car is much more important than the investment in a house. So that's also some idea for the business. So what we want to do is we want to deliver a quality product over the whole product life cycle, not only over the production. So that's the normal steps in developing an individualized product. You start with a concept, you do the development with the partners. After negotiation, the contract, you start with production and you distribute it and install it on the site. So that's the first part. And then we want to do quality assurance over a few decades, because that's the lifetime of that product. And that's somehow challenging. And we want to do this with modern IT technology to improve the quality. So that means, again, using cloud, sensors, IoT technology, big data, artificial intelligence, wearables, and also all these and other technologies. But still, it's a small and enterprise company. It's not an IT department with 100 people developing this. So their core competence still is carpentry. So that should be as small and easy to use as possible. So sensors, IoT of things. Well, what do we think? We think of the normal sensors we heard in a few talks before, like smart home data or city data. I call them, well, we want to look at the environment with the sensors. What is the temperature? What is the conditions in that area? We just want to collect that data. The product is the wall elements, and a lot of the walls are really visible in the house. So what we want to do, we want to take from time to time images of the surface of the wall. So just looking on the wall, you can looking for small changes in the gap between two blanks, for example, which would give you hints that there might be something to look at in the dynamics of the house and the static of the house. Is there pressure? Is there bending? All of that can be, we try to detect with image data. And we want to look inside the wall. For example, like temperature, moisture, with sensors, which we can easily put in there because of the production process of the wall, which is something which is called stack blank construction. So we can put between the blanks the sensors, and which we can read out because of the electromagnetic properties of the wall. The project is performed at the University in Mannheim, Duale Hochschule, in collaboration with the partner NUR-HOLZ and a company here in Böblingen. Techmo, which are strong in wearable computing, and it's funded by the Baden-Württemberg Stiftung, located in Stuttgart, and we started last year and got funding for 3 years. Thanks for the support. The goals of the system is, in principle, to bring the company from the Stone Age of IT to the rocket area a little bit. So what we want to do is we want to collect all data which we got during construction and the planning of the product. Based on that, later on we want to support the teams which are the constructing on-site, the building of the house, for example in Italy, in Japan. So if there is a problem, which from time to time occur, this should be supported by the system too. We want to get the data out of the house, we just talked about that. And if there is something which looks strange, we want to send our distribution partner there looking for pictures, annotate them if there is something looks strange, if we find a sensor which gives abnormal values. So that's another thing, that we get all quality relevant data within the system. And exactly, that is done with the local partners. And later on we want to run analytic systems which looks for abnormal quality situation like failings, shortcomings or design imperfections from the system. Our approach is, well, use existing technology, proven technology, so solid open source ecosystems. So we use software from the Eclipse Foundation. We will use Java with OSGi for the cloud and sensor runtime. So we want to build a system, we aim for building a system which makes no difference between the gateways in-houses and the analytics nodes in the cloud. We want to do this with a REST architecture using HTTPS and JSON. And for security, we will use X509 certificates for security and privacy, together with the JSON Web Security Framework. So that's how our system will look like. At the center is our server, that is our knowledge database. There everything about every house somehow will be stored, will be collected. We will have the desktops UIs from the engineers building the house, from the engineers of the partners, from architects and all of them. So all these nodes will access the AQUASI server, entering data, make a notification. All events should be recorded, which has to do with the production and the construction of the house. So there will be not only one desktop, there will be probably something like hundreds, which have to be managed. On the backend side, there's the server, and we will have the cloud storage system. So the data should be stored in the cloud, just uploading pictures we take, plans we do. We put everything in the cloud because there is no expertise running big servers over a long period in the company. So we use the service they delivered by cloud providers. And in the background, we'll have the analytical services. That's the nodes where we later on analyze the data, which is stored there. All the information we get from the AQUASI server, that will be analyzed in there. And, well, we have the sensor gateways, and all the sensors will send data to the knowledge database, to the analytical services, and even to the cloud storage. Interesting is that on these 4 systems, we use the same runtime based on OSGi. This is a third-party service, which is using RESTful services, and there will be tablets and wearables, which should be also integrated to make to be able to interact with the system later on. Come to that in a second. So there is a system where we use OSGi technology to manage the whole framework, and that's the overall architecture which we decided to, which was decided at the very beginning. Maybe we start from the upper layer, which is the presentation. We will have the desktops, we will have tablets, and we will have wearables to access data. There will be a service layer for the system, which is, for example, the analytics service or the service to make annotations and the domain-specific model projects for as an example, the house projects. We will have platform services. Definitely there should be something like security and identity. So this is the platform we aim to build when we talk about an open source platform for SMEs. That's more or less that part with the part of the services there. And for every customer, there should be specific services in the domain. Down there is our runtime. Based, for example, also everything should run in the cloud. That's the left part of it. So different cloud providers run Java, run OSGi. On top of that, we will install all the services. And we manage that with our inventors management runtime. And the same should be the case for the sensors. So even on sensors, we'll have Java, OSGi, and we access them or manage them with the same platform. For sure there will be non-Java part. This we try to reduce to the max. Also try to reduce to the max means use them as minimal as possible. So that's the provisioning system we built. Again, we have OSGi, Java, the operating system Java and OSGi. And on top of that is the AQUASI provisioning services, which is REST services running there. So we use the JAX REST container, HTTP server, and we use P2 of Eclipse for putting the service in this OSGi runtime. And all this runs on the cloud compute nodes, on the sensor nodes, and on the UI workstation nodes. Installing software should be done by a specific UI console, or call it perspective in the terminology of Eclipse. We take the metadata from the software repository. We inform every node with the provisioning service what kind of software is available and what kind of software should be installed in the system. And then it takes the software from the repository and installs everything in the framework. So then it's time for demo. Let's switch to the application, prototype application. This is just a pure E4 application. We have the good situation that we just started one year ago, so we decided to go for E4. Nothing about compatibility issues. And that's one of the perspective. We have the cloud management perspective, and that's the data we can access. We can, it's a little bit small, get information about the providers. And for example, here is just the data for our OpenStack cloud in our university. The data we get about this was really transferred now via my mobile phone from the server in Mannheim. I'm connected there via VPN. So that's every time we click there, we get communication and get the latest data from the server. This is the instances server. We have currently 2 gateways up in Mannheim with a given number, and there we want to install software. So we come up with the inventor's management perspective, and here you can list the instances. We look just for the gateways. There are 2 gateways available, and we just add repositories to them. When we select one, we see which bundles are installed, which components are installed. As everything here is P2, we can just select, for example, groups, which means features. And we see just the features which are installed there. And everything there is more or less AQUASI or either Inventor. So that is our runtime, which is there. And currently, this is based on 85 bundles are they called. So what we can do is we can add a repository. So just make the gateway repo. It has an URL, and it's this one. So can be improved. Gateway slash repo, and we go ahead. We select all of the nodes. We click finish, and it installs that. It communicates, sends the information to the nodes. The repository should be announced, and let's hope that everything went well. So yes, it's there, and now we have here just the installable units which we can install on the system. And we can just select here a feature, take the latest one, install it. Again, on all of the machines, just that one. We finish it, and it should install in the background. Yeah, it was just the background icon there. And if we now update the software system, we see that we have now installed another 3 bundles. So this is about managing the cloud infrastructure and the edge node. So that can be done quite easily with a perspective which we want to offer to the company. Okay, going back to the talk. This is then the next thing, how the project domain model would look like in the case of the house project. So at the part is definitely a house project, and there will be the social network. I call it social network of the product of the company, which are the partners. Partners might be architects, or might be montage partners, or might be distribution partners. So there will be different type of partners, and they exist anyhow. So that will be a basic service. And we will have the house project, which is composed of different other artifacts. So what are the deadlines in the project? That's quite important for the company, because they have already the books full for end of next year. So even that is challenging for them, even if they doubles the production line capacity this year. So what is the status? What kind of events occur in a house project? What are the sensors which we have in? What are the offerings? That's negotiation data which will be in the cloud and which should be accessible. There will be the construction plans, images which we take from the walls. All the things should be in the system, and that builds the model. And then for all of these entities, we decided to deliver something which we call then microservices. So this is a system based on endpoints which are REST services which we can access. The AQUASI server connects all these data by providing the data and the links to the children. We use the composite pattern there. And we have partners as another independent service from the project. The project domain model, everything in there is based on what we call the AQUASI composites. They have a description, they have data, they have children. And based on that, we can get the information. So for example, get information about a project. We just get the project itself, and first time only the links. And the second call, we get the children and the data of the project. So we have there a lazy loading concept explained here. So the client gets project 42. He only gets back the thin artifacts, means the children and their links. So when we want to know what kind of partners are in there, we can ask this project for its partners, and we get back again the thin artifacts. And in this case, this is a link to the partner 4711, famous number in Germany. And we get that back, and then we can call the partner service and get more information like bank account data and workers in the system. And this should also work with third-party services. So again, we want to get the offerings documents. We get back that this is with a cloud provider in a given folder, a given document. So when we have that REST endpoint, we just go to the cloud storage and take the data from there. So the system works even there. So that is then part demo 2. I will show you a little bit about the partners and the project, how we think how it should look like, and we will access the sensors which are currently operated in Mannheim. This is just a block of a wall, 75 centimeters square, and you see there are different layers, and in the different layers there are sensors which here are visualized to be in the wall. And now we're reading out really, I hope to get out data really from the sensors. I have to speed up a little bit. So these are then the domain perspectives. So we have just partners of data, and every time we download thing, we use the communication model which is there, and just a few people are in there. You can edit them. So we'll change this telephone number, so we can save them. It goes back to the cloud server, to our knowledge database. All the changes are made remotely. And we have the project perspective, which are just the just the information about different projects. That's located in there. We have editors for adding the project data. The status can be changed. The deadlines can be changed. There is no deadline in there, but it should be there. The partners involved. Offers, we can download documents from the cloud quite fast. That's just how the system is working. And oops, this is exactly the problem we have sometimes. The bug is already created. And just to give you a small feeling where the company is, it's that's the location of the company. So it's just south of Ludwigsburg, a little bit close there. Let's go to the gateways. So here we can announce with the well-known error and gateway, add a gateway, the gateway of floor number 1, which is has a specific URL or host name. Oh, let me just take that one, which is 1 and university, and we run the service there. And just by adding the gateway, it's in our model. We can accessing it, and what kind of sensor is there. We get all of them, and as mentioned before on the image, these are something like 18 sensors which are available, and just by accessing them, we get the data. It's only visualized currently as numbers, and the number is always 31 because that's a moisture sensor, and luckily it's quite dry in the room because it's the room of my computing center. If it's really wet, I would get nervous. And the measurement was just 2 hours ago, but that's because of UTC issues. So, and that means in principle we can read out all the sensors. That's the demo effect. So accessing the data, and this is really looking into the wall. Again, looking into the wall. It's not just I think never did that before. Okay. How much time do I have?
So according to schedule, 3 more minutes.
Okay, we started a little bit later.
2-3 minutes more.
Okay, so the platform we think about, or what we want to build, will contain currently the services to manage users and the certificates and the cloud infrastructure. And for each SMEs, we think that we have to adapt the domain services to their service need. I presented just you the first prototype of what we want to build with the company of these houses. So the next thing we did is we started with an I-40, in that case of SMEs, domain language to build it on Xtext. So which is using this AQUASI data and communication model, this very simple one, and the language should enable us to use to deliver services to other SMEs which have a different structure, a different use case, in high quality and in a short development time. So just creating all the UI aspects for E4, and later on we aim for build the same stuff even for other platforms like Android, Universal Platform, and the HoloLens. Students are currently working on this, and thanks to the Xtext project which we use there. So let's go to the right. Yes, UI. So that's just a text document which is there, and you see we have for our partners the composite which is defined, AQUASI composite or the AQUASI data object, and just by adding another value there, the UI will be created. And this is the one which we use for the cloud. So that's just the model of the cloud. UI is composed, and based off that, we get all the domain things created. So this is I have to stay in there. So the source generated just contains the data, the classes, for example, for the cloud, and UI composites, which we need, which we want to reuse in the system. So everything there is done, and we use that already for the development in the cloud perspective to prove that this is working fine. Oops, let's go back to PowerPoint. So this is the OSGi conference. So summarizing our vision, we think that OSGi is as reliable and good that we can put it in the center of the whole application, of the whole framework, in the cloud and on the edge nodes, and even on the UI nodes. We can enable and simple management for this AQUASI cloud, all the nodes distributed worldwide. We think that we can deliver software by them and even enable them management for non-expert SMEs. And our future is that we collect the data, and that with the help of analytics, we will answer questions like, how can I construct a wooden house on Hawaii using a blueprint of a house in Norway? What I have to change, the thickness of the wall, all the things we want to learn over the next few decades. That was my talk. I guess that's the last slide. Okay, thank you for your attention, and ready for question.
All right. Thank you, Harald. Any questions?
You said you're communicating with sensors. What kind of sensors or protocols, or this is out of?
Sorry? What we call, if you use electromagnetic waves to get data out of that, that's quite clear that these are RFID sensors which are in there. So which are in the wall, which we're communicating with.
Okay.
Because industry, for me, is more related to some industrial protocols like PLC.
Yeah, exactly. But this is, we came to the conclusion that as we want to build a system for houses which last quite long, we stay to the, want to reduce ourselves to things where we believe that they are still there, and this is HTTP. And the rest. So that's quite simple. That was the motivation for us to make it as simple as. I agree on that. OPC UA will be in the production line. We try to encapsulate them between a REST service, but the idea is, stay with fundamental things. Stuff has to last as long as a house exists. That's another challenge for building every 2 years new products. So that was the motivation. We can see there's good trade-offs and goods and bads, and this was our decision at the very first time. Okay.
So how about digital twins? Do you deal in any way with digital twins? Because I think this is something that is interesting. At least for Bosch, for production facilities. Plan the production side. Yeah. With digital twins, you simulate them, and then you basically set it up in reality, right? So.
Yeah, in principle we think on that. That's then the part when we think about analytics. So just, we discussed about the deadlines in the project. So in this area, the deadlines of a house is moving. The fundament is not there, the basement is not there, so it has to reschedule. It means the whole production has to be changed because the capacity of storage for them is limited. And even that is something where we think of the analytics service will do this from time to time, take the data of the knowledge base, put it in the digital twin, which is then on the analytics service, and does a rescheduling of the production scheduling, for example. So that's something where we really think on, that's then the digital twin representation in our case. Okay, so thank you. If there are no further questions.